Hi friends, today we are going to see the different segments in a Linux uh, process uh, or a program you can say. So basically what I'm trying to say is when you compile a normal program here, you will get a corresponding process. This A dot out is nothing but a process which is created from after compiling segments.c. So what is this process? What does it contain? So we are going to see that in detail here. So yeah. So in short, each process have these many sections or segments. We can call it as sections or segments. The more appropriate word is segment, and the first one is text segment. Basically, what it contains is the actual code and the instructions of a code that we are writing. This code uh, the some major part of this code will be more going to the code segment, and the next one is data segment. So which contains the static and global initialized variables. So we need to be careful that those variables, those static and global variables which are initialized, will be moving to the data segment. And the next one is BSS, which is actually a part of data segment, but it contains only uninitialized static and global variables. And the next one is heap. Heap, as you know, which is actually next to the data segment, but this can grow and reduce dynamically, and this section is used for allocating dynamic memory for the program. Uh, that means if you are using a malloc or calloc to allocate some memory to a pointer, then the corresponding memory will be taken from the heap. And the last one is stack. Stack basically contains the local variables and local, uh, not local functions, or uh, uh, like the reference to function calls, you can say. So these are the major segments when you examine a Linux process. Now let's see how each variables are saved. So as we explained, this int x. So as you know, it is a global variable, and this is not initialized. So since it is not initialized, it will go to BSS. And this next one, static in void. Again, it is a static global variable, and since it is not initialized, it will go to BSS. The next one is int is equal to 1, which is a global variable again, but this is an initialized global variable. So this will go to data section. This will go to the data segment. And the normal local variables like int a. Int a is normal local variable here. And this local variable will be saved in stack segment. Again, now if you see the static int b, you may you may think it is a local variable. Actually, scope of b is just local, just inside this function, but it is a static local variable. So since it is a static variable, the the process the this will be saved in data section. So why it is saved in data section? As you know, static int b equal to 3. When you do like this, the scope or the life of this b is till the depth of the actual process, just the uh, not just within the function calls. So it cannot be saved in stack. Stack is just for a function. When you call it as a stack, for each function, there will be some stack allocated for each function. So, for example, here suppose we have a function here, um, uh, which has some kind of data with some values or some variables. So, we can int 0 to 2. or something like that. So, and when you call a function from here, this function from here the compiler will allocate a allocate some some space or stack for function from. And it's a function name. Yeah. So this is how it is working actually. So the stack is just for the function calls and the function returns, and or some allocating some space for the function execution. But data segment is not like that. Since it is a static variable, the scope and the life of this B is till the death of the entire process, not just within this function. So, for example, we declare in static the int c as static int c, sorry, static int c. Then, if we call, if we just increment c to the 2, and as you know, if you just call it twice or thrice, but each time when you go inside, uh, the C will retain the old value. So for example, first time it comes with C will 2, and here it became 3, and it returns. And again, when it comes, the control comes back, the C won't be again initialized to 2. It retained the old value, that is 3. So that is the use of data section. The data section is for the entire process, and stack is for this function that's called. Hope you guys are able to understand the actual difference. Stack is for actual function uh, scope, but the data section and other sections are for it has a global scope, and the left hand the life the period of those their memories till the death of the process. So that is a major difference here. And again, this is really this is an important question. So, for example, we have let's, let's have these two declarations here: character asterisk str and character str1, which has an array. So, a lot of this is a really common question in interviews. What is the exact difference between these two? Again, so when you declare like this tells a compiler, okay, I have a data which is hello, uh, which is not going to change, and str is a pointer which is going to point this to this memory, to this uh, space, or to this memory. So when the compiler is saying this, it will allocate some memory uh, in, in a read-only area. That means this hello cannot be modified. So it will get saved in text or read-only data segment. That depends on the compiler. Again, it depends on the compiler. It can be saved either in text segment or in the read-only data segment. And when it comes to here, since the format is different and looks like an array, as you know, this will be saved in stack. So the best example here is you cannot. This will give can't do like this. We cannot, as I said, we can't change uh, the value of str. Even the str cannot be pointed to new place. Even x2 are invalid instruction. We give secondation fault or invalid instruction exception. So, but when it comes to str1, you can change. But this since it is local variable which is saved as temp, you can change the value at any time. So this operation is valid. This operation is a valid one. This is one of the most important questions or frequently asked question in interviews, and most of the candidates won't answer it correctly. Let's execute it and let's see how it is. We got a couple of warnings, but just ignore it. Yeah, we got a segmentation fault because, as I said, we tried to perform two invalid instructions there. So let's comment the two things. Or let's comment one instruction and see how it works. Again we got segmentation fault. That means still we have some issue in the code. Let's comment this too. See, there is no segmentation fault there. That means uh, there are these two lines are wrong. These two operations are not permitted. So how? So these are the basic uh, segments in process and how each variable are getting saved and the normal behavior of each variables and its scope and its storage. Hope you guys are able to understand the concept well, and please share your feedback or doubts in the comment section. Thank you.